Hello everyone, this is Benjamin Dono. This poster is about the set of competitions that we co-organized with Antoine Marot, Isabelle Guillon, and all other people. These competitions are called Learning to Run a Power Networks, and they aim at better operating the grid in real time. You don't know a lot about power grids? No problem, we've got you covered. Basically, a power grid is a tool that allows the transportation of electricity from producers to consumers over long distances, typically the size of countries, for example. As you can see on this poster, we draw a power grid where producers at the top are interconnected with consumers here at the bottom thanks to power lines. Okay, great. But why worrying about power grids right now? I mean, AI is the new electricity, right? Well, not exactly. The power grids are facing today unprecedented changes all around the globe. In some countries, especially in developing countries, it is crucial to develop the power grids as they are a key development factor. A strong power grid is also mandatory to power the increasing demand coming with economic growth. In other countries, for example in the US or in Western Europe, power grids are mainly made of aging infrastructures. They were built decades ago, in some cases just after World War I, almost 100 years ago. At the time, the use of power was completely different from today. These infrastructures need then to be adapted to fit the actual use. For example, when they were built, the environment was rather deterministic. Power was produced in some known localized area thanks to coal, gas, or nuclear power plants. And then this power was transported in other non-specific areas, cities, big industrial consumers, who had always the same consumption pattern. Today, more concurrency is happening between energy producers. This competition between the producers come along the introduction of intermittent energy sources distributed all across the grid. This dramatically affects the way the power flows are split in the grid. In all cases, to face these changes, multiple choices are possible. The first one is to do nothing. This is always a solution, but in this case, this will mean a slower increase of renewable energy and more frequent blackout for consumers. Not really great, right? Another solution is to rely heavily on new infrastructures, building new power lines, new substations, new transformers, etc. This solution was the preferred one for a long time, but it suffers some drawbacks. The first one is the cost associated to it. Indeed, building a new grid from scratch potentially costs hundreds, if not thousands of billions of dollars. The second drawback, in my opinion, especially in most developed countries, is the public acceptance. Why building another grid when there is one already working, you might ask. Finally, what becomes more and more important today is also the resources needed for such infrastructures, in the context of rarefaction of some of these resources. This is why we decided to start this set of competitions that we call Learning to Run a Power Networks to try a different approach. Indeed, we think that with a smarter power grid operation and planning, we could achieve more with less hardware. We believe that relying more on software could allow a better use of already present infrastructures and reduce the need to build heavy and costly new ones. And luckily for us, at that time, we have at our disposal today a wide variety of methods to tackle this complex issue. In fact, for this set of competitions, we decided to approach one of the problems faced by human operators today: how to choose the best power grid configuration that will allow the maximum flow to be transmitted in the grid as efficiently as possible, reducing the system losses, and of course, and most importantly, as safely as possible. This problem has been framed as a sequential decision-making that we model as a POMDP, a partially observable Markov decision process, suited to do reinforcement learning. In these settings, an agent will choose at each time step on which part of the power grid will act. For such purpose, we developed a full environment completely compatible with OpenAI Gene interface that we call Grid2Up, standing for Grid to Operate. This Python package is available on GitHub and PyPy. It's totally free and open source, and you can download it and play with it right now. It allows to interact with the Power Grid model quite easily using the standard OpenAI Gene API. It serves as a backbone for the competitions we are organizing. More precisely, your agents can receive an observation from a power grid. For example, how much power is produced at each node, how much power is consumed, or the flows on the power lines. For example, that we call, for example, OT for the observation at time t. And then your agent, here represented by a policy pi, is asked to take a decision opening or closing a breaker or switch to be as efficient as possible. On this example, you can see, or maybe not, that there is a problem on this power line right here. Too much flow is flowing on it. To reduce it, the agent in this case decided to open a switch located at this substation here, and this has the effect to modify the power grid and to isolate this part here from this part here, and it solves the issue. Wonderful, isn't it? Of course, you might think that power grids are highly critical systems. Who would short circuit a nuclear power plant? I mean, what can go wrong if you do that, of course? That is why of the motivation to cast this problem as competitions, because we think it is important to ensure reproducibility in such critical systems as a power grid. Having competition is also a way to ensure fairness in comparing different algorithms as they are all ranked using the same score function, using the same data. In this competition that are already happening here for the WCCI one, and that will start soon for the NeurIPS competition, you are asked to submit your code of your agent that is processed and then evaluated on our cells. Thanks to the work we have been put together in Grid2Up and all the environment we develop around it, we think that this will help improve the research in both reinforcement learning and also improve the power grid are operated for a more sustainable future. If you think your methods can train an agent that interacts with a complex, realistic, and challenging environment, come participate in our competition. You can also join us on our Discord for more information on this challenging issue. Thanks.